Hey there, I am Amin, and in this video I want to discuss in detail about the Converge CFD program and the simulation of a closed cycle diesel engine. This video is my first tutorial from the 3D CFD engine simulation series, and I will be with you in the future with other complete tutorials. 3D engine simulation may seem difficult to everyone, but once you simulate the first engine, you will fall in love with this subject. Regarding the production of electric motors, it should be noted that these engines are still considered an advanced technology and used and upgraded in various tools in developing countries, especially in countries that have more oil and gas reserves. At first, I want to do a closed cycle simulation, which is suitable for starting work with the engine 3D CFD, and it is much faster in terms of CPU time. My suggested program is Converge, because of being more user-friendly, and also this program allows to speed up the simulation with automatic and adaptive meshing. And with the example inside the program, you can learn it as quickly as possible. The first step is input the geometry file. To do this, I import the piston file from File, Import STL. Here make sure that the file is imported with the correct size unit. Only one piston geometry is needed to simulate the engine in this method. Because I want to do a simulation without symmetry, I prepared my own geometry with full and 316 degrees. Also, you can use Converge tool to create geometry with Make Engine Sector Surface. You just need parameters like bore, stroke, connecting rod, and 2D bowl or head geometry profile that you give it like a plot for Converge. In most simulations, due to spray and piston profile symmetry, and to speed up the calculation, we use a small segment of domain like this. As you can see, the mesh on this geometry is very small. You should know that the Converge calculations have nothing to do with the surface mesh quality, and the smaller amount of the triangles, the faster the solution speed. What is important here is the smoothness of complex places like piston ball. To have a proper and regular level grid, use meshing softwares and import the file in STL format in Converge. First, by pressing Ctrl+G, I open the geometry panel. From the View tab, you can see all of the shortcuts of the program. Now, from Boundary and Flag tab, you can see number of geometry facets. I want to make this mesh as simple as possible and get rid of unnecessary facets. For this, from the Repair and Delete tab, select the triangle from the top bar and choose by angle. Give level 1 degree so that only flat surfaces will be selected. Select the flat surfaces. And hit the Apply button. Note that one side of the edge must be connected to a surface, otherwise the edge will be completely removed. From the Patch tab, I select the By Edge option, and from the top bar, I select By Open Edge. Then I select the corner of the cylinder head that I removed, and I click Apply. You can see we deleted unnecessary triangles and created a surface with few facets. For the other surfaces, from the Create section, I select Triangle, Loft Edge, and choose by Arc. For the Active Set 1 box, select Origin Edge, and for box Set 2, I select the edge of the destination. I repeat this for the other parts too. One of the most common problems in simulation with moving mesh is intersection of triangles. So what you must do for simulating the engine is to delete the liner part and create it again, so that a proper and simple mesh is created in this part and all of the triangles are connected together. To do this, open the Repair and Delete tab and select angle less than 19 degrees to delete this surface. Now, with Create Triangles, Loft Edges, select the open edges of origin and destination and connect the cylinder head and piston together with a surface. You can see that a suitable and fine mesh is created in this section. Now, by pressing Ctrl+D or this stethoscope, or from the View tab, I enter the Diagnosis section. Note that geometry problems prevent the converge to run, and it is important to fix all of them. From below, I select Find. My geometry has intersections. By clicking Show, the places where it has problems are shown. These two surfaces intersect. As you can see, an extra surface in the geometry caused this problem. For fixing that, from the Geometry tab, I delete this surface with the Delete tool. Now again, from the Diagnosis panel, I hit Find. The problems of intersections and open edges are fixed. Now another problem is normal orientations. By pressing Ctrl+B, enter the View option and select Show All from the top. From the left bar, select the triangle shape with arrows. All of these arrows should be indicated the direction inside the geometry and the place fluid flow is ongoing. Using the Geometry and Transform section and selecting the Normal tab and Resolve selection, I select the surfaces that show the direction out of the geometry. After I select it, I click the Apply. By returning to the Diagnosis panel, I hit Find again. Now, all of the problems were solved, but one of the problems you may face is the incorrect size of the geometry. To see your geometry size, open the Message Log panel and click the information mark on the left bar. As you can see, the size in X and Y direction is about 100 meters. I solved this problem by using transform and scale with a coefficient of 0.001 and selecting the entire surface. Select the arrow shape from the left bar so the geometry fits on the screen. By selecting the information mark again, I check the size of the geometry. As you can see, the size of the geometry is about 0.1 meters or 10 centimeters. Now it is time to name the boundaries of the geometry. By going to the Geometry, Boundary, Find/Clean and pressing the Find button. We will fence the edges of the geometry boundaries to make it easier to choose the triangles. Now, from the Flag tab with the plus button, we create the name of the boundaries. Here, we have a fixed boundary of the cylinder head. and the liner, and the piston boundary, which is moving. Now, by changing the selection type to the boundary fence, select the triangles of the cylinder head and click on the head flag, then click Apply. Repeat this process for the other two boundaries. Make sure that no facets left without boundary name. Finally, our geometry is completely prepared for simulation. This part of the video has ended. It is continued in the second part, which deals with the settings of the in-cylinder combustion simulation.